Okay, so here's Stephanie, and she's thinking, you know what, this Social Security isn't enough. It's probably not going to be enough. I want to save in a different account, and she's thinking about a Roth IRA. She probably doesn't have a employer-sponsored retirement plan, like those employer plans where like you put in 10% and they put in 10%. Obviously, that's the best deal. Always pick that. But let's say you're Stephanie's self-employed or something. She's thinking, I'm going to try a Roth IRA, which is basically a retirement account for working people. Like, you don't pay taxes on the earnings inside of this. And that's the cool thing about a Roth IRA, okay? So in any case, she's thinking, okay, I'm 30 now, going to retire at age 65, and I'm going to die at about 90. So that's what this annuity is. And we should really talk about the fact that your money doesn't have to run out, because all you have to do is take out less and it'll last longer, right? So, and that's basically called a perpetuity. So if you want to just take out, live off of the interest, that's totally possible. So, but an annuity takes out a little bit of your principal and interest on this money you've built up. Anyway, so she's thinking, so I'm going to save up money because when I'm retired, she says, I want $2,000 per month for 25 years because I'm going to be retired from age 65 all the way to 90, right? So then the question is, okay, well, how much do I need to save up? Well, that depends actually on the interest rate. Now, the best I can do for y'all is to give you an interest rate of 6.8%. Because if you look at from 1971 to 2020, so from 1971 to the year 2020, the average stock market return was 10.9% in regular dollars. But if you adjust for inflation, because you all know how dollars are less valuable each year, right? Because we keep printing out more because it's just paper money, it's just fake money, right? Like all money is fake money, right? So the actual stock market return is 6.8% when you adjust for inflation. Basically, the US stock market over the last, since the 20s. Look how it goes up and down. And I was just talking earlier how, look, this is like 1928. And it's like 40%. So companies making lots of money. And all of a sudden, boom, they're in the red. And they're losing lots of money. And there's lots of job loss in the 30s. And that was called the Great Depression, right? That's the Great Depression right there in the 1930s. And that's showing up there in the graph, right? You see red is a depression and green is a boom, right? For corporate America and anyone that happens to benefit from it. All right. So anyway, what's this? This looks like about 2008 here. This big red bar. Remember 2008?
Yeah, the recession.
Right, there's a recession there, right? But then what happened? It jumped back up again. So by 2000, so if you had money on the stock market in 2008, you lost a whole lot. But don't worry, because by 2010, you had it back again anyway, or 2011, 2012, it was all back again. Don't worry, So the problem is like returns go up and down, but overall, if you just look at that graph visually, can you see more green or more red? Was it more green or more red?
Green.
Yeah, more green.
It's more green, exactly. So on average, it's doing well, right? On average, and that's what we got. Listen, average interest rates on the stock market or in a retirement account, they're ridiculous. They don't make any sense because this stuff goes up and down each year. But it does make sense when you're trying to plan out your life. Because this is what really happens. It goes ding, 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 right? But on average, you're looking at 6.8%. There's no guarantee. So yeah, because it's more green than red, because you can look at an average return of about 7% or so after adjusting for inflation. So that's where I came up with that. I just want to make this as real life as possible. So there you go. So that's what I'm trying to get to is, we can see that there's more green than red. We can see that with the stock market, there's more good years than bad years. And so it's pretty risky to just put money in the stock market and then hope to make money and take it out next year. Because it could be a red year, it could be a downturn, it could be two reds in a row. You could lose money next year and the next year. right? So therefore, how do we make money on the stock market? How does one do that? For sure, how do you really, without make it less risky? What's a less risky? What's a less risky way of making money on the stock market then? Now you're talking. Putting the money in there and forget about it. Exactly. And then it goes back to the philosophical question, who has money that they can just forget about, right? Because you might need money for food and shelter and all the basic needs, which is why the whole 1% thing, well, the 1% of the country, or maybe the top 10%, they got free money. They can just leave it there. They don't need it for housing and food and clothing and transportation and all the things, right? So there you go. And we're the 99% and all that, which is quite a valid concern. So anyway, but if you could possibly take advantage of it, you will get an average interest rate of about 6.8%. And moving on to here, what we've got to do is find the T, the R, and which formula we need. And so let's first of all figure out. Well, I guess we should probably figure out what formula we need first. Okay, yeah, let's do that. Okay, so the question is, what size nest egg Stephanie needs to achieve the desired annuity? What size nest egg? So if we look at our formula sheets then, everybody, what type of formula are we looking for? So here's my formula sheet from chapter 1. And let me see, I want to put this question beside that somehow. I need to fold the page. One sec. Fold the page. There we go. Okay. Okay, so there we go. So the question is, what size nest egg does Stephanie need to achieve the desired annuity? And what formula should we pick then? So, yeah. Well, that's the question. Is it this one? Because that has a nest egg something or other in there. But this one, look, there's a nest egg thing here. So I actually have two formulas that say nest egg in it, right? So let me try to walk that through. The annuity yield goal is the amount of money Stephanie hopes to get each month from a Roth IRA on top of Social Security. What is her annuity yield goal? Right? So let's go back to the question and try to figure that out. What is her annuity yield goal? Right. Right. She wants to make $2,000 per month for 25 years. All right. So what is her annuity yield goal? Annuity yield goal is the amount of money she hopes to get each month from a Roth IRA. What is her annuity yield goal? $2,000 per month. Exactly. Perfect. Perfect. $2,000 per month. Okay. What are we trying to calculate? This is the question. What are we looking for? Looking. What? Right. We're looking for the nest egg. That's what we're trying to calculate. Or in fact, so now looking at the formulas, let's go back to the formulas again. And I see two formulas with a nest egg in there somewhere. Now, which one is it? So yeah, you think it's the nest egg needed. Because that says the nest egg needed equals annuity yield goal. That's our $2,000, isn't it? Times all this stuff over all this other stuff, right? Okay, nice. Good, you're correct. Nest egg needed is what we are looking for. That's the formula, and we'll get back to it. But in that formula, there's an R and there's a T, two variables. Let's go find those variables. So I'm going to start with finding T. And first question I'm going to ask is, how many years will Stephanie be retired for? And I'll put that like that. Okay, let's find T. How many years will Stephanie be retired for? Good. 25 years. Okay, next question. How many months will Stephanie be retired for? Good job. 25 times 12 months in each year. That's 300 months. Now, in your formula, the variable T represents the number of months that Stephanie will be retired for. This is called the term of the annuity. The term of the annuity. So what does T equal? T equals 300. Perfect. So, and I like to nail these because if we don't nail them and get these right, then the whole thing falls apart. So we have to make sure we get these right. Okay, so next up is finding R. Now, nice and slow, step by step. What is the annual interest rate, the APR? And I want you all to give it as a percent and as a decimal. Good. 0.068. Perfect. What is the monthly interest rate? And the 6.8% is simply given right there in the question. That's the average annual interest rate, 6.8%, right? So what is the monthly interest rate? Good, good. In fact, I just need to write in APR. That's what I should have put there. Good. So 6.8% divided by 12. So let's give that as a percent and as a decimal just for fun. Both. Take your time. Right. Right. So, yeah. So let's see. I guess I'll do it up here. 6.8% over 12 is, I'm just going to say that's about 0.567%. So a little over 0.5%. So 0.567%. That's as a percentage now. A little over 0.5% per month, right? Because that's the monthly interest rate. And as a decimal then, 0.068. Yeah, go ahead. Right. So as a decimal, we can take this decimal 0.068 and just divide that by 12. 0.068, divide that by 12, and that's our monthly interest rate as a decimal. Now we're going to use the decimal in the calculation, because you can't use percents in calculations. You got to turn your percents to decimals, and then you can use them to calculate. I was just having you guys do everything because I just want to beat this problem to death and make it as transparent as possible. 0, 5, I'm going to go 6, 6, 7, just to, roughly that, because this is a never-ending decimal, right? Even better if you're calculating to leave it at 0.068 over 12 in your calculator. If you can do that, that is the most accurate way. If you want to round it, give it a bunch of digits, right? Okay, so in your formula, the variable R represents the monthly interest rate as a decimal. So everybody write down what R is. What is R in your formula? Yep, 0.005, and I'll just go 667 roughly. Or even better, it's the 0.068 over 12. So that's our R. That's what R is, right? Okay, so good. We've read the problem, comprehended it, understand. We talked about the limitations of this interest rate. We talked about how it's an average. Stock market goes up and down. So we beat that to death, and now we're ready to go. We have our formula for sure that we all know we need. We saw two formulas with a nest egg. I got confused as to which one, and then landed on this one. It has to be this, because look, it's nest egg needed equals, put the annuity yield goal in there. So, feel free to press pause at this point and calculate the nest egg needed, and then I'll go over it, okay? So we got annuity yield goal on the top. Times 1 plus r to the power of t minus 1. Annuity yield goal times 1 plus r to the power of t minus 1. Okay? So I'm going to write that. So annuity yield goal we figured out is the 2,000. That's going to be, let's see, just write, sorry. So it's going to be 2,000 times 1 plus r to the power of t. Let me see. I'm going to do it as 1 plus 0.068 over 12. That's 1 plus r. And then to the power of t, and then subtract 1. So I'm going to use another parentheses because I need to divide these numbers and then add 1. So I'm going to put this parenthesis there, and then it's going to be to the power of t. So I'm just going to do the whole thing as a calculator line. To the power of t, which is 300, and then minus 1. So that would be the top of the fraction. And then, so that's a new deal goal time multiple start power t minus 1. And then the bottom of the fraction is r times 1 plus r to the power of t, right? R times 1 plus r to the power of t. Right, so I'm going to go 0.068 over 12, that's r. And then times 1 plus r, 1 plus 0.068 over 12 to the power of t, which is 300. Now, and so both of these are going to calculate. And remember that your calculator is really good at the order. Oops, sorry, I didn't have that under. Okay, so this is r times 1 plus r to the power of t. Your calculator is awesome at PEMDAS. Okay, it knows order of operations really well. So, for example, on this one, it's going to do the inner parentheses first. And inside here, there's addition and division. Which of these is the calculator going to do first? Divide, right? Yeah, division. And then it's going to add, right? And then, after that inner parenthesis is worked out, you've got a subtraction and an exponent. Which is it going to do first, exponent or subtract? It's doing exponent, which is what we want, then subtract 1, and last of all, it'll multiply by 2,000. And so that will be your top, that will be your bottom, and that will all work out, right? The bottom here, it'll go inside here, it'll divide by 12 to get the 0.005666666 forever. The r, it'll do that. Inside this parentheses, it'll divide and then add, which is what you want, and then do the power, okay? So in other words, it'll get this inside this parentheses, then it'll get inside this parentheses, then it's going to do the exponent to 300, which is what we want, and then at the end it's going to multiply. So this, if you type this out, press enter, it'll work in your calculator. If you insist on doing an estimate with the decimals, you're welcome, and that would look like something like this. So if you did so that'll be the top, that'll be the bottom. Okay, I guess I'll go ahead and do that, and then I'll do the less accurate way afterwards. But 2,000 parenthesis 1 plus 0.068 over 12 to the power of 300, and then a little arrow and subtract 1. Right? Oops. Sorry. So anyway, that's my top here in the calculator. Written out just as typed in just as I wrote out. Then subtract 1, press enter, and it looks like 8895.48 so on, right? So I'm getting, 8895.486 and so on, right? The bottom of the fraction I'm going to go parenthesis 0.068 over 12, parenthesis again, 1 plus 0.068 over 12, close parenthesis, to the power of 300. And press enter. And the bottom should be about 0.030870, etc. Something like that, right? Now, on my calculator, I'm going to, without having to type these in again and estimate, I'm just going to use the arrow. I'm going to go up, highlight this one, press enter, and now it comes down. See that? Then I use the arrow, go up, highlight that, and press enter. And then that shows. Oops, I forgot to divide. Sorry. Go up, take that number, press enter, and divide. So that's the top, which needs to be divided by the bottom. You can type it in if you want, but I'm doing this. Highlight that, press enter. That divided by that, and we should get the nest egg needed is approximately, and I'm going to round out to the nearest $1,000. 288,000, right? So the goal is 288,000, right? And just for that calculation, I'm just going to go over it with the rounded R. So the top would be 2,000 times 1 plus R, which would be 1.005667 to the power of 300 minus 1. And the bottom would look like this. 0.005667, and then 1 plus R would look like this, 1.005667 to the power of 300. So if you want to put it this way in your calculator, that would also work, but that should be the top, that should be the bottom, and you should round to about 288,000. Are you okay with that? All right. So nest egg needed for Stephanie if she wants the $2,000 per month during retirement until she gets to 90, in which case it would run out. Depressing, is 288,000. But what we also need to think about is, well, if you don't want it to run out, then you don't take as much out, right? So instead of taking out, you would take out less, basically, right? So you take out, I don't know, whatever, 1,500 a month or so. But there's we can calculate that as well on how much you would take out to kind of make it last, right? Okay, cool.